Good morning, Year 9 and 10. This is Radioactivity Lesson 4. Today's driving question: how does one element turn into another element? What do you notice about these two lithium atoms? Okay, so there's two diagrams on the board. Press pause and have a think about what is different between these two lithium atoms. Okay, so the one on the left is how it exists in its stable state. Okay, so it's an element. It's not a charged particle. The one on the right is something has happened to it. So the lithium atom has lost one electron. So it's now, the diagram on the right only has two electrons, which are the crosses in the first shell, whereas on the first diagram it has three crosses. So there's two in the first shell and one in the next shell. So it's lost that one electron. Now, because it's lost that one electron, it's now become an ion, which is a charged particle. Now, the brackets on the right-hand diagram show that the whole ion is now positively charged because it's got less electrons than protons because it has lost an electron. So it now has an overall positive charge of +1. So most atoms have a stable nucleus. That means that they have the same number of protons and neutrons. Radioactive atoms are unstable, but they want to become stable. Now, they do this by giving out energy in the form of radiation. Now, ionization is where atoms gain or lose electrons. You've done this before. Now, by doing that, this turns them into charged particles, which we call ions. If an atom has lost electrons, it becomes a positive ion. So it means it's got a positive charge. It's got more protons than electrons. Whereas if an atom has gained electrons, it's now become a negative ion because it has more electrons than protons. Now you'll remember that electrons are negatively charged. So if it has more negative electrons, more negative charges, that's why it becomes negatively charged overall. Now there are three different types of radiation. Top one is alpha, then we have beta, and then we have gamma. Now we're just going to watch a video on the three different types.
In 1895, Henri Becquerel, he's the man with the moustache, discovered that rocks of uranium affected photographic paper. This is the rock of uranium that he looked at, and it's called uranyl nitrate. If you look at it, you can see it's yellow. It shouldn't be yellow, that's because it's giving off light. This means that there is some evidence in the rock that there's energy being given off, which affects the paper and which gives out this light. This was the first evidence of radioactivity. However, there was no indication of what this energy source was. It was only with the discovery of other radioactive materials that a pattern started to emerge. The radiation got sorted into three types. We're going to talk about these three types now. So let's introduce the first one. Here comes alpha. Alpha radiation is very easily stopped. It's stopped by air. Look, it just goes into the air and stops. Even a piece of paper, if you put a piece of paper in front of alpha radiation, it can't go any further. It's also strongly affected by a magnetic field. So here we've got a whole beam of alpha particles, and these alpha particles are going through a magnetic field. And when they go through the magnetic field, they bend quite a lot. This tells us two things. One, that it's the heaviest of the radioactive particles, and two, it's the most heavily charged type of radiation. The symbol for alpha is this, the Greek letter alpha. It's not very penetrating. That means if it actually hits something, it stops. Penetrating tells you how far it can get through things. The second type of radiation is more difficult to stop. So in other words, it's more penetrating. it is stopped by about 0.5 centimetre of aluminium. And although it's affected by a magnetic field, so remember the alpha particles bending off to the right, then the beta particles would bend off to the left. This is beta radiation. It's much lighter than alpha radiation, and the particles have got a negative charge as opposed to a +2 charge on the alpha radiation. This is a symbol for beta radiation. The most penetrating of the types of radiation is gamma radiation. Gamma radiation goes furthest in air, it goes a long way in air, and also it goes through aluminium. But it will get stopped by lead. Gamma radiation is not a particle like the other two. Gamma radiation is a wave. That means it's just pure energy, which goes up and down as it goes through the air. And because it's got no charge, and it's got no mass either, it just keeps going. And it's very, very difficult to stop. So gamma radiation is the most penetrating. It has no charge and it has no mass. And it's not affected by a magnetic field.
Okay, so the penetration power of the three types of radiation. So we've got alpha at the top. Okay, it's stopped by air, skin, paper. Beta is able to get through some thin materials. It's able to get through skin, paper, but it's not able to get through aluminium. Whereas gamma can get through most things and is reduced by lead, thick lead, concrete. So which statement is false? A, alpha radiation is the most ionizing. B, gamma radiation is the most penetrating. C, beta radiation is a slow neutron. Or D, gamma is on the electromagnetic spectrum as it is a wave. Press pause to answer. Okay, the correct answer is C, because beta radiation is not a slow neutron, it's a high-speed electron. That's the answer, the statement that is false. Okay, so now this moves on to our tasks. Again, for the first task, we have a slide here with a table. Now, if you have a printer, this is on your Show My Homework with supporting documents. It's another assignment that you can print and fill it in. Or if you prefer, you can just sketch out the table and write in your answers. Probably need quite a big piece of paper, so either A4 or A3. At the top, there is a website, okay, that you can use to give you some further information. Okay, we can use your revision guide if you have one. That's the first task. Grade 4 to 5 is to finish these sentences. So nuclear radiation comes from, and it is emitted because. Ionizing radiation is, the most ionizing form is, and the most penetrating is. So if you complete the sentences. Grade 6 to 7, explain which source is the most dangerous in your body and which is the most dangerous source to have in the same room. And grade 8 to 9, explain why an element changes during alpha and beta decay, but not during gamma decay. That's your blue task. Press pause to have a go at the tasks. Okay, so now we're going to go through the answers. So get your different colour pen or green pen ready, please, to tick and correct your work and to add in any extra detail if needed. Okay, so the summary table of alpha, beta, gamma. Okay, so you can see on the board, if you press pause, you can now mark your answers. Okay, grade 4 to 5, nuclear radiation comes from an unstable nucleus, and it is emitted because the nucleus has an imbalance of charges and wants to become stable. It does this by emitting energy. Ionizing radiation is energy in the form of alpha, beta, or gamma. And the most ionizing form is alpha, the most penetrating is gamma. Grade 6 to 7, the most dangerous in your body is alpha. It's the most ionizing and is stopped by skin. So once inside the body, it can't get out of the body and will ionize the cells around it, causing mutations. Most dangerous source to have in the same room is gamma, as it is the most penetrating, so it can get into the body easily. If you're exposed to gamma rays, they pass through your entire body, affecting all of your tissues, from your skin to the marrow of your bones. This causes widespread systematic damage. And grade 8 to 9, A nucleus changes into a new element by emitting alpha or beta particles. These changes are described using nuclear equations. We'll do more on this next lesson. Gamma is pure energy and will not change the structure of the nucleus in any way because it's a wave. Press pause to mark your answers. Okay, and now we're on to our sentence. So today I achieved, state, explain, use or combine. Because I can, you write down or summarise what's in the boxes next to the statement you have achieved. Press pause. Okay, so the final task is on Show My Homework. Don't forget there is a 10-question quiz on there. Please complete this and the quiz results will be emailed to your parents or carers, and this helps us to see that you have done the work. Thank you. Have a good day.